Okay, so in this section, what we're going to be working on now, we're going to be taking our triangles and we're going to be doing the distance and the midpoint of certain line segments. So when we work with distance, whenever we're on a coordinate plane, and I know that this is a little bit not a great coordinate plane, but this is the best that I can work with here. So if we have a coordinate plane here, okay, and we want to find the distance between 2 points. Let's say I wanted to find the distance between the points P, where it's at the point 4, 3, and Q, where Q is at the point 1, negative 2. Okay? So basically what that's going to be showing us is, if I'm working with my coordinate plane here, I'm going to graph my points. I'm going to graph the point P, which is 4, 3. So I'm going to have the point right here. That's the point P. And then the point Q is going to be at 1, negative 2. So that's going to be right here. So I'm going to want to find the distance between these 2 points. So the problem with this is I can't just count. If it's a horizontal or vertical line, I can kind of just count up or down, left or right to determine the distance. But here, because this is not a vertical or horizontal line, I can't just count. So what I have to do is I have to use my distance formula. And the distance formula says that the distance between any 2 points, point 1 and point 2, where the first point we're calling x1, y1, and the second point we're calling x2, y2, the distance formula is d, which is the distance, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So because we have a formula, all we have to really do is take my 2 points and plug it into the formula. So in the case of the problem that we have here, if I were to take my x1, y1, x2, and y2 and plug it into the distance formula, we would get that my distance is going to equal the square root of x2 in this case is 1 minus x1 is 4 squared plus y2 is negative 2 minus y1 is 3 squared. Well, now all I have to do is take whatever's inside and do PEMDAS. So PEMDAS tells me to do inside parentheses first. So 1 minus 4. 1 minus 4 will give me negative 3 squared. Negative 2 minus 3 is going to give me negative 5 squared. Then I raise it to the power. So negative 3 squared. Negative 3 times negative 3 is positive 9. Negative 5 squared, negative 5 times negative 5 is positive 25. Then I'm going to add what we have underneath the radical. So 25 plus 9 is 36. And in this case, it actually works out... 25 plus 9 is not 36. 25 plus 9 is 34. So 25 plus 9 is 34, so I'm ending up with the square root of 34. So now here, we're going to want to try to simplify the square root of 34. So I'm going to put this part over here. So the square root of 34, we need to find our perfect squares again. Remember, this is back from section 1 in chapter 10. We work with all of our perfect squares. 34 lands right here. So I'm going to check all of my numbers that are lower than 36. So I do 34 divided by 25. That doesn't work. Divided by 16 doesn't work. Divided by 9 doesn't work. And divided by 4, none of these work. So this is actually the simplified version of our radical. So if it asks us to leave it in radical form, my answer would just be the square root of 34. It might also ask me to round it to the nearest tenth or hundredth or whatever it may be. If that's the case, then I just take that and plug it into the calculator, and the approximate answer when I plug in the square root of 34 is going to be approximately 5.83. And again, I will always tell you if I want you to simplify it as a radical or if I want you to round it to the nearest decimal. So this is rounding, and this is if I say simplify as a radical. So it really all depends on whether I ask you to leave it as a radical or to round it. But this is the distance between my point P and my point Q here. So that's how you find the distance between 2 points. You just use your distance formula. And again, it really is just take the 2 points, plug them in, and then do PEMDAS to get your answer. So let's try another one of these. Let's do one more together. So let's say I have the points R as 6, -2, and the point S as 12, 8. And again, I want to find the distance between my 2 points. The good thing about distance formula is I don't have to graph it. There really is no point in graphing this because I can't count it anyway. Just take my 2 points, first label them, meaning this is my x1 and y1. This is my x2 and y2. Then we write out our distance formula. We know that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now I get to take everything and just plug it in. My x2 is 12, so this is going to be the square root of 12 minus x1 is 6 squared plus y2 is 8 minus y1 is -2 squared. So 12 minus 6, that's going to give me a 6. And then 8 minus -2, minus negative becomes plus, so this is technically saying 8 plus 2, and 8 plus 2 is 10 squared. So now I square what I have inside. We have this square root of 6 squared is 36, plus 10 squared is 100. So we end up having the square root of 136. Now, for this one, let's actually take this and we're going to leave it as a radical. We're going to simplify this as a radical. We're not going to take this, plug it into the calculator, and round it. So we want to simplify as a radical the square root of 136. So again, we go to our perfect squares. Alright, we can stop there because 136 falls right here. So I'm going to check every one of these numbers that are above 121. If I try 136 divided by 121, that does not work. 100 doesn't. 81 doesn't. 64 doesn't. 49, 36, 25, all of those don't work. But when I divide it by... Oh, sorry, no, 16 and 9 don't work. But when I divide it by 4... Sorry about that. When I divide it by 4, I do get that 136 can split up into 4 times 34, which then gives me the square root of 4 and the square root of 36, and the square root of 4 we know is just 2. So my final answer would be 2 radical 36. So when I ask you to simplify it as a radical, I want you to do this process. We did this process back in section 1. You had it on the quiz, so it's nothing new to you. Just have to kind of relook it over to, brush off some of the cobwebs that you may have. All right, so I've given you 2 different problems here, and I would like you to pause the video here and try and find the distance between these 2 points. So I want you to find the distance between point P and point Q, and then I want you to find the distance between point R and point S. So remember your distance formula that we just talked about. If you need to, rewind the video, look at the distance, but try these ones on your own and see if we can figure out what they are. So here are the 2 answers that we get. For both of them, we don't actually have to simplify them. They are as simplified as possible. The square root of 10 can't be simplified. Square root of 97 can't be simplified. But for this one, we just have to make sure that we are putting the first is x1, the second is y1. Here we have x2 and y2. And then making sure that when we look here, -5 minus -2, that's going to give us -3. -3 minus -4, that's going to give us 1. Alright, so the next thing we want to talk about is midpoint. So, kind of the same concept as distance. We're still going to be given 2 endpoints. Let's say that we have the endpoints here. P is at 5, -10, and Q is at 5, 8. But instead of finding the distance between these 2, let's say I wanted to find the midpoint. Obviously, the midpoint is the point that's directly in the middle of these 2 points. So in order to find the midpoint, what I'm going to want to do, again, is I want to use a formula, which in this case is called the midpoint formula. So the midpoint formula is M, which is your midpoint, is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. Now, as you see, this formula is a little weird because it's in the shape of, or in the form of a point, which makes perfect sense because we want our answer to be a point. We want an x value and a y value. So when we're using the midpoint formula, what we're actually doing is here, we're finding the average of my 2 x values. I'm going to take the 2 x values, I'm going to add them together and divide it by 2, find the average. I'm going to do the same thing with the y values. I'm going to take the 2 y values, add them together, and divide it by 2. I'm just finding the average. So when finding the midpoint, it's just the average of the x values and the average of the y values, and then that's going to be my final midpoint. So for this problem here, working with my x's, I would plug in 5 plus 5 over 2. And then working with my y's, I would plug in -10 plus 8 over 2. And then I would just combine them. 5 plus 5 is 10. -10 plus 8 is -2. And then 10 over 2, that's going to give us 5. And negative 2 over 2, that's going to give me negative 1. So my midpoint M is going to be at the point 5, negative 1. All right, let's try one more together. Let's say I wanted to find the midpoint of the 2 points, 3, 0. Oh, sorry, 0, 3. And we'll call that point R, and point S, which is at 5, 0. So again, if I'm looking for the midpoint, I want to use the midpoint formula. So the midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2, the average of the x values, comma, the average of the y values. So I'm going to start with my x values. I have a 0 and a 5. So it's going to be 0 plus 5 over 2. Then I'm going to move on to my y values. We have a 3 and a 0, so it's going to be 3 plus 0 over 2. 0 plus 5 is 5 over 2. 3 plus 0 is 3 over 2. Now, I can just leave it just like that. I don't have to change these into decimal approximations. I can just leave it as the midpoint would be 5 halves, comma, 3 halves. All right, why make more work for ourselves if we don't have to? It's already in the form of a fraction, so the only thing that I would have to do maybe is simplify it. But seeing as it's over 2, it should be simple as that. Don't put it as a decimal. Leave it as a fraction. But this would be my final answer. It would be the midpoint of 5 halves and 3 halves. Or 5 halves, comma, 3 halves. Okay, so again, I have 2 problems up here that I would like you to try on your own. So pause the video here. I want you to try to find the midpoint between the points A and B. And I want you to also find the midpoint between the points J and K. So as we see my answers here, for the midpoint of A and B, we should have gotten a midpoint of negative 1/2, comma, 0. Again, negative 4 plus 3, that gives us negative 1. I don't have to simplify it. Negative 1 plus negative 1 does give me 0. And then 0 over 2 just simplifies to be 0. On the other side, 3 plus 2 is 5. 5 over 2 doesn't simplify, so I leave it as 5 halves. And then negative 17 plus negative 8, that's going to be negative 17 minus 8, which is negative 25. And negative 25 over 2 does not simplify, so I leave it as negative 25 over 2. Now I want to do a little bit of a challenge problem with you here. And the reason I want to do a challenge problem is because obviously we have a test coming up, so I want to make sure that you're understanding at least this section pretty well. So let's say that we have our triangle here, ABC. So we have a triangle ABC. All that that means is that we have a triangle, okay, and the 3 corners, the 3 vertices is what we technically call them, they're just labeled A, B, and C. Okay? So we know that triangle ABC has points. A, we'll say, has a point of negative 2, 4. B is at the point 2, 3. And C is at the point negative 1, negative 3. Okay? So for this question, what I want to know is this triangle an equilateral triangle? Is it isosceles? Or is it scalene? So before we go into actually solving this problem, we kind of have to talk about what each of these three words mean. Equilateral, isosceles, and scalene. Well, equilateral just means that all the sides are equal. All sides are equal. Equilateral, they're all the same. Isosceles means that only two sides are equal. Okay, it doesn't matter what two. It could be A and B, and it could be side AB and side AC. Could be BC and AB, could be BC and AC. Just has to be two of the sides. Scalene means that none of the sides are equal. Okay, so this is important. So what this tells us, if I want to know how many of these sides are equal in distance, well, that means that I'm going to want to use the distance formula. Well, a triangle has three sides. So that means I'm going to have to do the distance formula 3 times. I have to find the distance of AB. I have to find the distance of BC. And I have to find the distance of AC. So I have to do the distance formula 3 different times. Okay, so let's start by finding the distance of side AB. If I want to find the distance of side AB, I'm going to use the points A and B. Seems obvious. So if I want to find the distance of that, I'm going to do my distance formula. Now, if we remember the distance formula, I'll put that up here. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So for this one, if I'm using A and B, my x2 is 2 minus my x1 is negative 2 squared plus my y2 is 3, my y1 is 4, and now I just simplify this. So 2 minus negative 2, that's going to be 4. 3 minus 4, that's negative 1. 4 squared is 16. Negative 1 squared is 1. So the distance of AC is equal to the square root of 17. Now, for this one, I don't even have to actually simplify it. If it doesn't tell me to simplify, we can just leave it as whatever the square root is, because really all we're looking for here are what sides are equal. Do I have equal sides? So I don't have to simplify anything. We can just say that the distance of AB is the square root of 17. All right, so now let's do the distance of BC. So now we're going to do the distance of BC here. So now I'm working with B and C. That's going to be the X and the Y that I work with here. Probably going to have to start writing a little bit smaller just to make sure I fit this all in here. But the distance of BC, my x2 is now negative 1 minus my x1 is now 2 squared plus my y2 is negative 3 minus my y1 is 3. I now go and simplify this. Negative 1 minus 2, that's going to be negative 3. Negative 3 minus 3, that's going to be negative 6. Negative 3 squared, that's going to be a positive 9. Negative 6 squared, that is a positive 36. So 9 plus 36 is going to be 45. So the distance of side BC is going to be the square root of 45. So just by doing these two sides, I now know that this is not equilateral. Right? I know it's not equilateral because I don't have all three sides the same. I just did two of them, and these two are different. So it's not equilateral. It can't be equilateral. But we're still not sure about the other two. It may be isosceles, it may be scalene. So I have to do the third one. I have to do the distance of AC. So now I'm working with A and C. So here my x2 is going to be -1 minus my my x1 of -2 squared, my y2 -3, my y1 -4 squared. So I go to simplify this. -1 minus -2, this is -1 plus 2. So -1 plus 2 is actually 1. And then -3 minus 4, this is going to be -7 squared. So I go and I simplify that. 1 squared, that's going to be 1. -7 squared, that's going to be 49. So this is going to end up being the square root of 50. And now that I look at all three of my distances, I see that all three of them are different. So that is going to leave that the correct answer here is that this is a scalene triangle, because none of the three sides have the same distance. So that's how we would work with a problem like this. If I'm giving you a triangle and I want to know what type it is, you have to find the distance of all three sides. So side AB, side BC, and side AC. And then just look at the distances. If two of those distances are the same, then it's isosceles. If they're all the same, then it's equilateral. And if none of them are the same, then it's scalene.